You and I. Yo, we are back. We are back. We are back for our next session of the day. We are having a crash course in AI from Samsara. Today with us, we have McLean Farrell. McLean is a senior emerging talent recruiter at Samsara and is excited to share more about how Samsara is transforming the digital operations industry. With us, we also have Abner Ayalo. Abner is an artificial intelligence and computer vision expert with 8 years of industry experience at several stages, such as research labs, Series A, Series C, and pre-IPO. He's excited to talk to you all today about the challenges and solutions of artificial intelligence. With that being said, I want to see all the emojis. I want y'all to welcome them in the chat. Absolutely. Give it up for the Samsara team.
Awesome. Thank you, Michelle Adana. Hi, everyone, for Color Stack. We're so excited to be here today. And let's dive into our presentation, A Crash Course in AI. So Michelle Adana already gave us some awesome intros, but I will just introduce myself very quickly. My name is McLean. I'm one of our emerging talent recruiters here at Samsara, have been here for the past year and a half, and I'm based in Boston. I'll pass it over to Abner to introduce himself.
Hey everyone, I'm Abner. I'm a senior applied scientist at Samsara, and I've been at Samsara for 3 years, and I've been working in the space of deep learning and computer vision for the last 8 years.
Awesome. So let's dive into a quick agenda. We just did our intros. I'm next going to go into a brief overview about Samsara, and then we'll get to the good stuff. Abner is going to show us a crash course in AI. I'll quickly share about our open roles, and at the end, we will open it up for some Q&A. We're really excited to hear and answer your questions. But I always like to start off showing this video about Samsara. So I'm just going to hit.
Physical operations keep the world running. It's how milk gets from the dairy to the table, how the places where we live and work are built, how our kids get to school safely, how our communities stay clean, how the lights stay on and the energy flows. To make it all happen, it takes people who wake up every morning ready to do the impossible. In a time when everything is accelerating like never before. So how do we make the impossible possible? How can we build factories faster than ever? Prevent crashes before they happen? Get emergency supplies to those in need? We can do it all together with one platform that empowers the people who power the world. With AI tools in everyone's hands, insights that drive better decisions, partnership you can trust to stay ahead of the curve. It's why we're here. Because now is the time to change the way the world operates. Now is the time to make more possible.
Awesome. That just gives me chills. We don't need to watch it again. It just gives me chills every time. So Samsara, we are an IoT company leading the digital transformation of physical operations. Our platform is the Connected Operations Cloud. Our mission is to improve the safety, efficiency, and sustainability of the operations that power our economy. So what do we mean by connected operations? At its core, we have the cameras with AI detection capabilities and trackers that go into vehicles or into work sites. We also have trackers that can be put on powered assets like trailers or unpowered assets like dumpsters. Our customers' employees can also use our applications to do things like track their drive time or fill out paperwork. All this said, the foundation of our platform is data. We help our customers collect and make actionable in the cloud. We use our own US designed and Samsara manufactured sensors to collect data from vehicles, such as the vehicle gateways or dash cameras that you see here on the screen, from sites using the site cameras, from equipment using the AGs and IGs. All of these devices are cloud enabled, transmitting data directly to the cloud where that data is synthesized and delivered to our customers so that they can make real-time quick decisions. How does this all work? Basically, all of the data that we collect from all those different devices flow into the cloud. From there, we process it, aggregate it, and enrich it, and run it through our AI and machine learning models, which you'll learn a little bit about today. Today, we see about 6 trillion data points in the cloud annually, and we use that data to train our AI models. From here, you can see just how extensive our platform is and all the different uses our technology has. This top row of the slide shows our product lines that leverage AI models to help our customers the most. Some of these different features include allowing our customers to coach drivers on safe driving based on videos we capture using AI detection. Our customers can track where their vehicles are and understand how efficiently they're running, understand their driver's driving time and make it easy for drivers to fill out forms and communicate with them, find stolen assets and understand how their trailers and assets are being utilized, and get visibility into their work sites using AI-powered cameras. Talking about Samsara, we have to talk about our culture. As a company, we were founded in 2015 and have had a tremendous amount of growth in a short amount of time. We went public in 2021. We just about a month and a half ago here at the end of 2023 officially surpassed $1 billion in annual recurring revenue, and are very excited to hit that most recent milestone. We have grown through incorporating customer feedback into our platform and, of course, hiring talented and hardworking individuals to build these solutions. Our culture is what is going to enable us to continue to grow and develop more tooling and more features for our customers every year. Our culture is defined by our 5 core values up on the screen, which unite all of our employees and give us a shared foundation. These include focus on the customer success, build for the long term, adopt a growth mindset, which I always think of our students when I think of that core value, be inclusive, and my personal favorite, win as a team. These are the values we strive to live by every day. They help us in the pursuit of our mission to increase the safety, efficiency, and sustainability of the operations that power the global economy. I'll now pass it over to Abner to discuss AI.
Thanks, McLean. Today, I want to talk to you about the challenges of AI in production, as that is something you don't get to experience when learning about AI in school. To put it into perspective, throughout the presentation, I will use a use case of building an AI model to detect hard hats. Imagine our customers want to know when people are not wearing the safety hard hats on certain areas. At a high level, we can have challenges such as data quality, garbage in, garbage out. It doesn't matter how great is your model if you have poor quality data set. Usually in academia, we work with data sets already created, or we can make a publication with a new data set we have created that can take months or years to refine. Scalability. What works for 10 users does not necessarily work for 10,000 people. Imagine cooking your favorite recipe for 10 people versus cooking it for 10,000. The process will radically change. Regulatory considerations. Similar to data quality, we may not be able to use all the data due to regulatory compliances such as GDPR, HIPAA, privacy concerns, or ethical concerns. This is how I like to break down the AI pipeline during development. I split it into data, modeling, and deployment. Modeling is the one you're mainly learning in school, but I argue is the one that you will spend the least amount of time. Now we will go over each of them in detail. Challenges in data collection. Access to relevant data. Data can be dispersed across various sources, making it difficult to gather all the necessary data to solve your problem. Data volume. You may not have enough data to build an AI model, or it could be the complete opposite. Like here at Samsara, we have too much data, so selecting which data is important and it becomes crucial. Imagine you have trillions of minutes of video to build a hard hat model, like I mentioned. Where do you start? Data imbalance. If there is a type of color of hard hat that is not very common, how do you ensure your model performs well on it? Data infrastructure. In order to solve these data-related challenges, you need to have the right data infrastructure to store, transform, search, visualize, and understand your data. At the end, the most important thing is you need to understand your data. Now we have collected the data, but we must decide which one to use. Here, we can use stratified sampling, which I show at the left, where we sample evenly across categories where we want our model to perform well, such as day versus night, sunny versus cloudy, or geography, for example, US versus EU. Anything that might be relevant to your model or product. But even when we have the most advanced sampling, it's still hard to find that needle in the haystack. Imagine you need to find pink hard hats, like on the image to the right. How do you ensure your dataset has those examples? For that, we actually have turned to the latest trend on multimodal models, similar to GPT Vision, where we search for rare events using text prompts. Let's say we now have sampled our data. We need to label it. During labeling, challenges such as annotation quality, annotation cost, and subjectivity could arise. For example, during annotation quality, here at Samsara, we outsource labeling to ensure that it scales, but we have rigorous review process to ensure labeling quality is met. After all, our models is only as good as what our labelers teaches them. Annotation cost. We mentioned already the importance of data sampling because labeling all the data is time-consuming and too costly. Subjectivity. Ensure your labeling is objective and consistent, even if it means having a different definition than that of the model. For this presentation, we won't talk too much about how to build a model because you can usually cover that in your AI courses. However, I want to emphasize a few things. Assumptions, assumptions, assumptions. It is extremely important that you understand under what circumstances does your model work or does not work. You need to know your data, you need to know your product. I'll give you a more concrete example. We deploy a product that was producing really good results on all of our evaluations. But once we deploy it, we noticed the model was not doing as well. Upon further investigation, we noticed that the pre-processing between production and offline evaluations were different. When we trained the model, we were resizing an image without keeping the aspect ratio. But in production, we were resizing without keeping the aspect ratio. Sorry, in training, we were actually keeping the aspect ratio, but in production, we were not keeping the aspect ratio. That means we were squeezing the image. It takes only a single wrong assumption to destroy your model performance and all your hard work. Whenever possible, emulate production constraints during model development. After you build your model and understand its constraints, it's time to optimize your model. This could involve conversion to ensure your model works on the right hardware, model quantization or model pruning for trade-offs between accuracy and throughput. This constraint can limit the type of architecture you can use, the size of model, and which layers can be used or need to be rewritten for compatibility. And how do we evaluate our model? We should focus on measuring both offline evaluation and online evaluation whenever possible. As I mentioned before, aim to emulate production environment as closely as possible during your evaluation. Here, we're not just talking about validation dataset. For example, for the hard hat use case, the model could have been trained using only images. So our training and validation datasets are only image level datasets. But for evaluation, we ideally want to use a video and an inference pipeline that closely simulates production environment. A very common occurrence is that we can have high accuracy during our offline evaluation, but the real-world performance of our models is much lower. We'll discuss a bit more about this during deployment. We are ready to deploy our AI model, but the reality is our ML code is just a small component in a much larger system with many services. In this picture, the black box illustrates the ML component. Continuing our discussion of model evaluation, we want to not only evaluate the model performance, but the entire pipeline performance. This is an illustration of a simple pipeline for detecting a cat I found online. The highlighted components is the model, but any of the components before or after can impact the model performance. So it is imperative that you measure your model performance at as many stages as possible, even for such a simple task. Let's say the model seems to be performing well when integrated into the pipeline. What is next? Well, we want to continuously monitor the model performance with key performance indicator, also known as KPIs, and build observability dashboards. We also want to understand our failure modes and how we can address some of these failure modes in the future. Remember, AI models have uncertainty. It will work under some cases and it will not work under others. So you really need to understand your failure modes. We also need to explain under what conditions our model works. Be prepared to answer any questions related to your model. For this, sometimes SQL can be your friend. Today, I talk about many of the challenges and steps needed to get an AI model into production. This is not to discourage you, but to highlight other skill sets you should learn to become a great AI or ML engineer. Here are some of the high-level recommendations. Start small. Adopt an iterative approach to model development and refinement. Continuously incorporate feedback and improvements. Seek understanding. Seek system-level understanding of all the moving parts that could impact the value proposition of your model. Remember, it's not about your model, it's about the impact and value that your model brings to a product. Stay focused. AI models are complex and have uncertainty. There are just too many knobs and things that could go wrong. So focus on simplicity and achieving your goals. Invest in data infrastructure. Develop robust data infrastructure to support data collection, storage, and pre-processing. And as a student, feel free to take a few courses related to data infrastructure. Monitor performance. Continuously monitor the model's performance and evaluate its accuracy and reliability at all stages. Implement feedback loops and regular updates to improve the model performance over time. Now, I'll pass it to McLean to discuss opportunities at Samsara.
Thank you, Abner. All of our US roles are posted on Ripple Match. The link should be pinned to the top of the discussion here. And then our global roles are posted on our Samsara career site. For any questions you may have, feel free to reach out to myself and my team at university-recruiting@samsara.com. Currently open and currently recruiting for a few different roles here at Samsara to join us, including the machine learning engineer, a computer vision intern that would be joining Abner's team. So if you like what you heard today and want to explore more, definitely excited to meet with some of you for this position. But now let's open it up to the Q&A. I'm going to stop sharing my screen so I can come back and we can answer any questions. Okay, so here we go. What are some current real-world applications of AI that are making a significant impact, and what makes these applications successful? Abner, take it away.
Wow. I mean, there's a reason why AI is so popular nowadays, right? There's just too many examples of where AI is just either changing the way we do things or so on. I'll just give you a brief example here at Samsara, right? Uh, One of the things where I believe we give a lot of value and impact to our customers, it's we have these dashcam cameras that basically are trying to understand driver behavior. So most people assume that we're just trying to make sure that drivers are doing what they need to be doing. But actually, the main benefit is the driving coaching application. So it's basically allowing um, the managers to basically train their drivers. And just by doing that, they get so many benefits of just reducing the number of accidents, being able to train very quickly with real examples, their new customers, and so on, right? I can go on going about many examples, right? Of course, everybody nowadays know about ChatGPT and its implications. Uh, so honestly, I feel like AI just keeps evolving, and it's really hard to say how it's going to end. But we already know that it is pretty significant and it's having a lot of impacts in our daily lives.
So thanks, Abner. Let's go to the next question. Can AI ever achieve a form of consciousness that mirrors human or animal consciousness? What would be the implications of such a development? That's a loaded question.
Yeah, yeah. I try not to get into the predictive mindset, right? I'm thinking overall humans, we try to predict the future, and usually you see that reflected in movies, but turns out the reality over the few decades doesn't necessarily match those expectations. Um, but you can see AI, it's getting closer and closer to mimicking human level intelligence, right? I guess that's consciousness. I think there is the key word, right? I guess it's how do you define consciousness, right? But for sure, we're getting to the level where we're having a system that is going to be able to answer most of the questions any human can answer, right?
It's a little bit spooky to think about. What
Yeah.
what influence does the sampling method used have on the accuracy of the model built? So I think this is pertaining to that pink hard hat example.
A huge one for sure. Yeah, to be quite honest, we spend a lot of time trying to significantly improve how we sample, not just sample, but first of all, how do we collect the data? And then how do we sample it? How do we ensure that we have the right labeling definitions so that we can translate that into consistent model, right? At the end of the day, as I mentioned, it's garbage in and garbage out. So data quality, data sampling, everything related to data, it's pretty significant. I myself have spent a significant amount of my time building just purely data sampling pipelines here where we use basically other AI models to determine what gets sampled, right? What is important and so on.
Awesome. Great question. What are the most exciting areas of AI research and development that promise significant advancements or transformations in the near future?
Well, of course, you have to mention generative AI, right? It's in the news every day, right? Whether it's generative AI or NVIDIA doing well in the stock, right? There's just too much momentum in it. I think particularly the excitement there is that we know it's very useful. We just don't know all of the applications that it has and what will be like the application that is the most successful related to generative AI, right? So that's why there's still a lot of intrigue and curiosity, but still a lot of excitement of what is the main go-to application and how does it really lead to a significant impact, right? Because at the end of the day, it's value. We still haven't found the main value of generative AI, I would say, although it already has a lot of value just by what we have today. But I think that is the most exciting, right? Like, what is the go-to application that has the most impact in humanity or society when it comes to generative AI? Yeah.
So, thanks, Abner. How can we best position ourselves for the workforce considering AI's capabilities?
Yes, that one is tricky. Of course, you try to, nowadays in school, there's plenty of AI courses. When I was at school, it was mostly graduate courses, but nowadays it's pretty common to have undergraduate courses focuses on AI, right? So of course, try to take as many courses, even if you're not in AI necessarily specialization. You can still take those courses to learn about them. Most of these courses will focus more on the theory, right? And I think that was one of the goals of my presentation, right? That there's the theory part about how to build a model. And for that, yeah, just try to get very comfortable at learning PyTorch, right? PyTorch, I think, is today the main framework for building AI models, or the most popular. Besides that, I would say just try to get good at being a good software engineer or even a data engineer in general, right? I think that's what's going to make you stand out from the rest, right? Because at the end of the day, you do spend a lot of time working with data. And although you're hired to build AI models, they're still just, you still need to learn all the software skills, right? So you still need to get comfortable with the tech stack of any software company such as Samsara, right? So just be good at being a software engineer. So don't only focus on learning about AI, right?
I think you had another tip too around the data infrastructure courses that they should.
Yes, exactly. Yeah, that's more like you don't have, sometimes you don't really, sometimes you can learn these skills once you join a company, right? So it's not like you have to have data engineering skills to get an AI role, but the more comfortable you are, whether it's with something as simple as doing SQL, right? Or the more comfortable you are at building data pipelines, right? With that, which is mostly what data engineers do, the better you will be at self-serving yourself, right? When you're building a model, uh, you don't want to fully depend on someone else to collect your data, right? I mean, you can, right? But it just helps a lot the more skills that you have so that you can self-serve yourself, right?
So, thanks, Abner. What are some drawbacks that have come with the use of AI in Samsara's business? Ooh, I don't know about that. Our business is doing pretty well with using AI.
Well, um, I think this is a good one, right? Because when Sansara started, we were not necessarily AI product, right? Or we didn't have any AI features per se, right? I think Sansara started as a telematics product first, right? So basically, that was mostly about getting information from the vehicle and deploying that information, whether it's for routing purposes, right? So AI came, a little bit later, but today is pretty crucial in our business. Specifically, one of our most popular products, right, is the dash cams, as I mentioned before, and that one is heavily focused on AI features, right? Some of the drawbacks that come from AI, I think, it's pretty hard to say specifically for Sansara. So, but I can, I guess, mention about what are some of the difficulties, right? As I was trying to allude to in the presentation, is that in software engineering, there is a bug or there is a problem, right? Or there is something that the customer needs. And you just simply work on that, you solve it, and you're done, right? Or you give it maintenance, right? But in AI, you're it's not binary, right? It's basically fuzzy logic. Your AI model is going to work under some circumstances, but it's actually going to fail under others, right? So that adds a lot of uncertainty. That makes it a little bit harder to do like triage or support, right? When you're talking about customer support, right? Or how do you ensure you give the best experience to your customer? So you have to, really hone that over time.
Awesome. This next question is going to be our final question that we answer here today. What sorts of decisions might AI systems make more fairly than humans, or vice versa?
Um, More fairly than humans. You know, I guess this is a little bit more personal opinion, right? But I think some of the things that make us human today is right, like we know when to apply the rules or when maybe rules doesn't necessarily apply, right? When to have that human touch of, right? There's these circumstances, but maybe we don't have to be fully objective, right? So I think some of the subjectivity of being human, right, it's what keep us human to some degree, right? Uh, so what you're trying to say, what makes an AI system more fairly than humans? To be honest, today most AI systems are learning from humans, right? So I wouldn't say that they can be more fairly. There will be more objective, right? We try to make them more objective, right? So maybe there's some fairness in that objectivity, but AIs are nothing more than systems that are trying to learn the patterns that we humans teach them, right? We have to label something in order for them to learn over that, right?
Awesome. Well, thank you all so much for the great questions, the great discussion in the chat. We really appreciated you spending a little bit of your afternoon with us and getting to learn more about AI and Samsara.
Yes, absolutely. Thank you so much, Samsara. Y'all give it up for Samsara one more time. Yes, I hope you are seeing all the emojis and all the thank yous in the chat. Thank you so much for spending your afternoon with us. I know folks got that good information. Absolutely. So thank you so much for being with us at Fam Friday today. With that being said, we're going to have a very short transition period to roundtables to network. So make sure to go into the lounge space for that, or chapter formation tables as well. And at 3 p.m., we will be chatting with NVIDIA about building your personal brand. So I will see you all again at 3 p.m. All right? Have fun. Go network. Go network. Stop it. Go network.